Dear students, welcome to our YouTube channel Chem Origin. This is Dr. Satish Kumar.
Students, we successfully completed the concept of fourth year group elements. So students, up to now from our channel, we completely discussed about third year group elements. Later we saw fourth year group elements. Now we discuss the lesson hydrogen and its compounds. Students, this is very interesting and very easy concept in our syllabus. Hydrogen and its compounds. So in this lesson we discussed about hydrogen, what are the chemical properties of hydrogen, and what are the important compounds, and what are the applications of compounds of hydrogen. We discussed in detail in this lesson. So students, hydrogen and its compounds, the new video module class, hydrogen and its compounds. So in this lesson, first we can start with the position of hydrogen in the periodic table. So students, there is a lot of discussions on the position of hydrogen in the periodic table. So what are the objections and supports we can see in detail. So students, we are very well known about hydrogen. Hydrogen is the first element in the entire periodic table, and it has only one single electron, and its electronic configuration is 1s1. 1s1. So students, hydrogen electronic configuration is 1s1. We are very well known about this one because it has only one single electron. So this is the lightest element in the periodic table. It has the smallest size, very smaller size, only single energy level. Okay, so students, its atomic number is 1. Hydrogen's atomic number is 1, and it is the first element in the periodic table. And the next one, the electron configuration. The electron configuration of hydrogen, the equal to the valency configuration of alkali metals. So students, we already know about alkali metals or nothing but S block elements, that is 1A group elements. 1A group elements, lithium, sodium, potassium, rubidium, cesium and francium. So these alkali metals have ns1 valency configuration. So in its valency shell, they are having single electron. Similar to alkali metals, hydrogen also having 1s1, a single electron in its valency shell. So students, hydrogen is also similar to alkali metals. It is having the electronic configuration, valency electronic configuration is S1 configuration. Therefore, generally in the periodic table, we placed hydrogen in the 1A group elements. 1A group elements. But there is some contradiction that the ionization energy of hydrogen is very high. Students, we know very well about ionization energy. It is also called ionization enthalpy. It is also known as a ionization potential. Ionization energy, ionization enthalpy, ionization potential. So all these are the synonyms to each other. Okay students, but the ionization energy of hydrogen is very high. So students, we are very familiar with the definition of ionization energy. The energy required to remove an electron from a valency shell, from a neutral isolated gaseous atoms valency shell, is called ionization energy. So the ionization energy of hydrogen is very high, whereas the alkali metals have very low ionization energy. That's why the alkali metals easily donates its valency electron. Its valency electron, it donates very easily, because after loss of its valency electron, after donation of its valence electron, it resembles with the nearest noble gas configuration or nearest inert gas configuration. So that's why alkali metals very easily donates its valence electron, whereas and it is having low ionization energies, but the hydrogen is having very higher ionization energy. And one more thing is that students, like halogens, hydrogen is one electron short to the nearest inert gas configuration. Means after gain of one electron, hydrogen reaches its electronic configuration nearest inert gas configuration, that is helium. So students, we are very well known about this helium. Helium's atomic number is 2 and its electronic configuration is 1s2. So students, hydrogen after gain of one electron, its electronic configuration is similar to the its nearest inert gas helium's configuration, that is 1s2 configuration. So similarly, halogens also, its electronic configuration, one electron short to its nearest gas configuration. For example, if you see fluorine, its atomic number is 9. So, and its electronic configuration is 1s2, 2s2, 2p5. After gain of one electron, it reaches its nearest inert gas neon's configuration. Its nearest inert gas is neon. So after gain of one electron, fluorine reaches its nearest inert gas. Similarly, if you see chlorine, so its atomic number is 17. Its atomic number is 17 and it is also one electron short to the nearest inert gas configuration. So if you see the electronic configuration of chlorine, its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. So it is one electron short to the argon. After gain of one electron, chlorine's electronic configuration is equal to the or similar to the its nearest inert gas argon's configuration. So like halogens, hydrogen also one electron short to its nearest inert gas configuration. So there is a controversy between whether the hydrogen is belongs to halogen group or whether it belongs to a alkali metals group or 1a group. Okay, so in detail we can see now. Next one, resemblance with alkali metals. Resemblance. Students, resemblance means similarity or equality with alkali metals. So students, some properties of hydrogen are similarly like alkali metals. So what are those? We can see one by one in detail. First one is electronic configuration. Electronic configuration. Students, we know the electronic configuration of hydrogen is 1s1, 1s1, and alkali metals general electronic configuration is ns1. ns1 is the general electronic configuration of alkali metals. Therefore, students, like alkali metals, hydrogen is also having one electron, single electron in its valence shell. Students, we know alkali metals, lithium, sodium, potassium, rubidium, cesium, francium have only one electron in its valence shell. That's why its general electronic configuration is ns1. Similarly, hydrogen is also having one single electron in its valence shell. Next resemblance with alkali metals is electropositive character. Electropositive character. So students, like alkali metals, hydrogen also donates one electron and forms a corresponding cation. So after loss of one electron, hydrogen forms H plus ion. Similarly, students, we know students about alkali metals. Alkali metals is also called electropositive metals. Electropositive metals. Therefore, alkali metals have one electron in its valence shell. After loss of that single electron, alkali metals configuration is equals to its nearest inert gas configuration. In case of lithium, after loss of one electron, its electronic configuration is equal to helium configuration. In case of sodium, after loss of one electron, after donation of one electron, its electronic configuration is identical with neon, nearest inert gas configuration. So similar to alkali metals, hydrogen is also after donation or loss of one electron, it forms a cation, means that electropositive. Therefore, we can give a statement is that like alkali metals, hydrogen is also electropositive character. And also students, uh, These next one is valency. So students, like alkali metals, hydrogen is also a monovalent atom, monovalent monovalent atom, and also strong reducing nature, strong reducing and monovalent like alkali metals. Next resemblance is liberation at the cathode. Liberation at the cathode. Students, if you see the electrolysis of water, the hydrogen is liberated at cathode only. So when you see the electrolysis of water, H2 gas, hydrogen is liberated at cathode. Similarly, if you see the during electrolysis of molten alkali metal salts. For example, if you see alkali metal salt, sodium chloride, potassium chloride, if you see the electrolysis of these alkali metals, what's happened at the cathode, alkali metal is deposited. So similarly, like alkali metals, at cathode, hydrogen is liberated during the electrolysis of water. So in case of alkali metals, the electrolysis of molten alkali metal salts, the alkali metal is deposited at the same cathode. Hydrogen is liberated at cathode. Similarly, alkali metal is deposited at cathode during electrolysis. So about this electrolysis, you can clearly learn in the next concepts. Next resemblance with alkali metal is reducing nature. Reducing nature. So students, like alkali metals, hydrogen is also acts as a reducing agent. For example, if you see iron oxide, if you take, so this hydrogen removes oxygen from iron, it forms a iron metal and water molecule is formed. Similarly, students, we know alkali metals acts as a reducing agents. So for example, B2O3 when treated with a alkali metal like potassium, it forms a potassium oxide plus boron. So here hydrogen acts as a removing the oxygen. So students, we already learned the stoichiometry lesson. In the stoichiometry lesson, the definition we are very well known. Removal of oxygen, addition of hydrogen is called reduction, and the element which participates to remove the oxygen is called as a reducing agent. Therefore, like alkali metals, hydrogen is also acts as a reducing agent. So hydrogen removes oxygen from oxides like alkali metals. So hydrogen acts as a strong reducing agent. It removes oxygen from oxides. Next resemblance with alkali metals is affinity for electronegative elements. So students, hydrogen is having very strong affinity towards electronegative elements. So students, we are very well known about electronegativity. So the electronegative elements in the periodic table is fluorine, oxygen, halogens. Generally, these are the highly electronegative elements in the periodic table. So with that electronegative elements, the hydrogen is having strong affinity towards highly electronegative elements like oxygen, sulfur, halogens, and react with them to form a corresponding compounds. For example, hydrogen reacts with electronegative element oxygen, it forms water molecule. Or if it is react with an electronegative sulfur, it forms a H2S. Similarly, if it is reacts with an electronegative atom like chlorine or fluorine, it forms a HCl, hydrochloric acid. Whenever the hydrogen reacts with a chlorine, it forms a HCl, hydrochloric acid. Similarly, alkali metals, this is already we know students, alkali metals are electropositive metals. So they readily reacts with electronegative elements like hydrogen, also alkali metals strong affinity towards electronegative elements. For example, if you see sodium is a alkali metal. So it reacts with oxygen, it forms Na2O, or it reacts with sulfur, it forms Na2S, or it reacts with chlorine, it forms NaCl, sodium chloride, sodium chloride. So student, these are the resemblance or similarities with alkali metals. So hydrogen having some similarities with alkali metals. Those are electronic configuration, electropositive character, valency, liberation at cathode, reducing nature, affinity for electronegative elements. So these are the some similarities between hydrogen and alkali metals. Hydrogen and alkali metals. Next one, differences from alkali metals. Students, just now we saw similarities with alkali metals. Hydrogen have some similarities like alkali metals, but there are some differences from alkali metals. Hydrogen also show some differences with alkali metals. What are those? We can see in detail. First one is ionic size. Students, if you see H plus ion, hydrogen ion's atomic size is very small. H plus ion, hydrogen ions size is very small when compared with the alkali metal ions size. If you see Li plus ion or Na plus ion, sodium cation, lithium cation, when you compare the ionic size of the hydrogen with the ionic size of the alkali metal ions like lithium cation, sodium cation, potassium cation, hydrogen's ionic size is very small. Next difference from alkali metals is ionization enthalpy or ionization energy or ionization potential. So students, ionization enthalpy definition we are very well known. The energy required to remove an electron from a neutral isolated gaseous atom's valence shell is called ionization enthalpy. In case of ionization enthalpy, the hydrogen's ionization enthalpy or ionization energy is very high when compared with the ionization enthalpy of alkali metals. For example, see students, alkali metals can easily donate its valence electron. That's why we are used these alkali metals in the photoelectric effect. Photoelectric effect. Students, in the lesson of atomic structure, we are very familiar with the photoelectric effect. Whenever a light is fall on a alkali metal, then electrons are ejected immediately. This phenomenon is called photoelectric effect. But here the ionization energy of hydrogen is high when compared with the alkali metals. So hydrogen's ionization enthalpy is high, but alkali metals ionization enthalpy is low. So this is the difference with the alkali metals. For example, if you see the ionization energy of lithium is 520 kilojoules per mole, whereas hydrogen's ionization enthalpy is 1312 kilojoules per mole. So this is somewhat near to the ionization enthalpy of halogens. For example, if you see the ionization enthalpy of fluorine is around 1680 kilojoules per mole. So there is a difference, more difference between the ionization enthalpy of hydrogen from alkali metals. When you compare the hydrogen ionization energy with alkali metals, hydrogen's ionization energy is high, whereas alkali metals ionization energy is low. That's why we are used in photoelectric effect. We are used, alkali metals are used in the phenomenon of photoelectric effect. So alkali metals are having low ionization energy, but hydrogen is having higher ionization energy. Next difference is anion formation. Anion formation. Students, alkali metals are electropositive nature. So if you see lithium, sodium, potassium, generally these are always forms positive ions, cations, Li plus ion, Na plus ion, K plus ion, means they can donate its valency electron. But students, hydrogen has an ability, it accepts a single electron and forms a H minus ion. H minus ion. H minus anion. H minus anion is formed from hydrogen, but alkali metals does not form anion, but hydrogen has ability to form a H minus ion. So this is also one difference with the alkali metals. Next one is atomicity. Atomicity. Students, hydrogen is a diatomic molecule, means it always exists as a H2. Hydrogen is a diatomic molecule. Hydrogen is a diatomic molecule. Hydrogen is a diatomic molecule, whereas alkali metals are monoatomic. Lithium metal ion, lithium metal, sodium metal, potassium metal. So alkali metals are monoatomic, monoatomic, but hydrogen is a diatomic molecule. So this is also one difference from compared with the alkali metals. Next one is non-metallic character. Students, we know very well hydrogen is a non-metal. Hydrogen is a non-metal. But alkali metals, 1A group elements are metals. Alkali metals, if you see lithium, sodium, potassium, rubidium, all these are metals. But hydrogen is a non-metal. So students, these are the differences between hydrogen and alkalis. So we saw there are some similarities between hydrogen and alkali metals. Similarly, there are some differences between hydrogen and alkali metals. The differences are the difference in ionic size, ionization energy, anion formation, atomicity, non-metallic character. So these are the differences of hydrogen when we compared with alkali metals. So students, we saw the similarities with alkali metals. There are some properties similarly with alkali metals of hydrogen. Similarly, there are some differences between hydrogen and alkali metals we can see. And likewise, hydrogen have some similarity with halogens, some similarities with halogens. So what are those? We can see one by one. First one is electronic configuration. Students, hydrogen electronic configuration is 1s1. So after gain of one electron, its electronic configuration is equal to the matches to the stable configuration that equals to nearest inert gas configuration helium. After gain of one electron, hydrogen forms a stable electronic configuration, its nearest inert gas configuration helium. So students, if you see halogens, fluorine, chlorine, bromine, iodine, after gain of one single electron, its configuration is attains stable configuration, its nearest inert gas configuration. For example, fluorine, its atomic number is 9. After gain of one electron, its electronic configuration is identical with the its nearest inert gas configuration, neon. Similarly, for example, if you see chlorine, its atomic number is 17. So after gain of one electron, chlorine's configuration is similar with the nearest inert gas, argon's configuration. So students, hydrogen have similar electronic configuration like halogens. After taken off one electron, its electronic configuration is stable configuration that equals to its nearest inert gas configuration. So this is the one similarity between hydrogen with halogens. Next one is ionization enthalpy. Ionization enthalpy. Students, in the previous slide just now we discussed the ionization energy of hydrogen is around 1312 kilojoules per mole. 1312 kilojoules per mole. So this is somewhat near to the halogens. For example, if you see chlorine, students, chlorine's ionization energy is approximately 1252 kilojoules per mole. 1252 kilojoules per mole. So students, hydrogen's ionization enthalpy is somewhat nearer to the halogen's ionization energies. So this is the next similarity of hydrogen with halogens. the ionization enthalpy of hydrogen is near to the halogen's ionization enthalpy or ionization energy. This is the second similarity between hydrogen and halogens. And the next one is liberation at cathode. So students, halogens are liberation at anode. Liberation at anode. So students, generally halogens are liberated at anode. So like halogens, hydrogen has a ability to liberate at anode also. If you see metal hydrides, in case of metal hydrides, what happen? The hydrogen is liberated at anode. So students, like halogens, hydrogen is liberated at anode. This is the next similarity of hydrogen with halogens. Next one is atomicity. Atomicity. Students, hydrogen forms diatomic molecule. Hydrogen exists as a diatomic molecule. For example, H2. So, students, we know halogens exist as a diatomic molecule. F2, Cl2, Br2, I2. So, students, like halogens, hydrogen is a diatomic molecule. Halogens are diatomic molecules. We know very well. F2, Cl2, Br2, I2. So, students, like halogens, hydrogen is a diatomic molecule. Next similarity is non-metallic character. Non-metallic character. Students, we know hydrogen is a non-metal. Hydrogen is a non-metal, whereas 1A group elements are metals. Lithium, sodium, potassium, rubidium, cesium are metals, but hydrogen is a non-metal. You can see halogens, fluorine, chlorine, bromine, iodine, all these are non-metals. So students, similar to halogens, hydrogen is a non-metallic nature or non-metallic character. Next one is electronegative character. Electronegative character. Students, halogens are electronegative. We know, students. So because of this electronegative nature, generally halogens accepts a electron from nearest element or atom, forms a corresponding anion. For example, if you see chlorine after acceptance of one electron, it forms a Cl minus anion, chloride anion. Similarly, like halogens, hydrogen is also has a ability. It accepts an electron, forms a corresponding anion. Corresponding anion. Therefore, students, hydrogen forms anion by accepting an electron like halogens. So, students, these are the similarities of hydrogen with halogens. Electronic configuration, ionization enthalpy, liberation at the anode, atomicity, non-metallic character, and electronegative character. So, these are the resemblance of hydrogen with halogens. Next, the differences between hydrogen and halogens. So students, just now we discussed about the similarities of hydrogen with halogens, but there are some differences between hydrogen and halogens. So what are those? We can see. First one is reactivity. Reactivity. Students, generally halogens are highly reactive at room temperature only. At room temperature only, halogens are highly reactive. But hydrogen is not that much reactive like halogens at room temperature. So this is the difference between the hydrogen and halogen. Halogens are highly reactive at room temperature, but hydrogen is not that much reactive like halogens at room temperature. Next difference between hydrogen and halogens is tendency to form negative ion. So students, however, hydrogen forms anion, but its formation is very low when compared with halogens. So students, halogens readily forms anion by abstracting, by taking an electron. But hydrogen is not that much readily accepts an electron and forms anion. So students, we can give a statement is that the anion formation of hydrogen is very low when compared with halogens. Halogens are very fastly forms an anion, but hydrogen is not that much rapidly forms anion. So the formation of anion with hydrogen is very slow when compared with halogens. Next difference from halogens of hydrogen is hydrogen bonding. Hydrogen bonding. Hydrogen bonding. Students, we know about this hydrogen bonding. In the SEM 1 we learned this one. So chemical bonding concept, the last topic, hydrogen bonding. Hydrogen can form a temporary bond with a highly electronegative element of another molecule is called hydrogen bonding. So student, only hydrogen has only the capability of formation of hydrogen bonding, but halogens does not form hydrogen bonding like hydrogen. So this is one difference of the hydrogen from halogens. Hydrogen has an ability to form a hydrogen bonding, but halogens does not form those type of like hydrogen bonding type. So this is the one main difference between hydrogen and halogen. So students, based on these discussions, we give a conclusion is that hydrogen have some similarities with alkali metals. So what are the similarities? We saw there are some similarities of hydrogen with alkalids, but as well as there are some differences with alkali metals. Similarly, with halogens also there are some similarities between hydrogen and halogens, and also just now we saw differences from halogens. So then we can give you a conclusion is that hydrogen have some similarities with alkali metals and halogens, and also there are some differences with halogens and alkali metals. Therefore, based on that, finally the hydrogen is placed in the 1A group at the top of the alkali metals based on their electronic configuration. So students, hydrogen's electronic configuration is 1s1. So finally, based on the electronic configuration similarity, hydrogen is placed at the top of the 1A group elements. Okay, but there are some similarities between halogens and differences between halogen. Similarly, hydrogen is also having some similarities with alkali metals and differences. Therefore, based on all these aspects, finally, according to electronic configuration, hydrogen is generally placed at the top of the alkali metals based on their similarities in electronic configuration. Similarities in electronic configuration, hydrogen is placed in 1A group. So students, I hope you enjoyed this session. Today we discussed about the hydrogen and its compounds lesson introduction. So students, in the coming next video modules, we clearly discussed about the interesting concepts of hydrogen and its compounds. So students, you can follow my YouTube channel and learn the concepts of hydrogen and its compounds in an easy manner. Thank you, and thank you very much.